Some time ago, someone decided that they would use a square as a unit measure of surface area. There we are, there's a square. And the advantage of this is that, is that when you put them next to each other, there's no gap between, and it is quite a straightforward shape to use in calculation. There's no gaps between. If you had circles, well, that would be a different matter. Let me demonstrate, see if I can get this to show you what I mean. Copy 1, 2, 3, 4, and here we go. Let's see if they, oh good, they move. Yeah, I wasn't sure. And yeah, 2. Come on, 3. Let me put that one there, or if you like, there. Let's line them up that way. You can see there's gaps. There's gaps in here. So this is a much more logical type of thing to do. You can get other shapes where there's no gaps, but this is a very straightforward shape to use in calculation. Alright, step 1 in a way of thinking. Suppose we have a rectangle, and there it is. Let's fill that in. Let's go for that, and hopefully this will work. There we go. We got a rectangle. Now to work out the area, you have this length here, and multiply it by that length, and that gives you the square area. But suppose it wasn't a complete filled in area like this, but a path that went round the edge. Now constructively, to build the path, we'd have this rectangle, and we can remove the bit in the middle to give us the path. Now suppose this rectangle here is area, oh, what's happening here? Hang on a minute. There we are. Has an area A. Whatever it happens to be, it's A, the value of that area of the red. Now if we remove or build, if we build a rectangle that goes in the middle, like this, and we'll go for white. You still see the letter A, and this is area B. The white is area B, the red is the whole thing. What we end up with, in fact, is not just A, but we have A remove B. A is the whole thing, everything. Absolutely everything. It is this length multiplied by that length. B is this length here multiplied by that length. We remove the white from the whole thing, and that gives us the bit round the edge. Straightforward. We can do an example of that. I'm just I'm just showing you the ideas behind the process. This is called area by difference. If you want to work out the red part, you have the area of the whole thing, remove from that the area of the inner part. They would have to give you the dimensions where you could work out those. Again, looking at just the idea without doing any calculations, suppose we have a rectangle. There we go, a rectangle. And we were, the area of the rectangle is that length there times that length there. That gives us the square area. Now if we were to draw a line, and I'm going to choose that corner to that corner there, we have two triangles. This triangle here is exactly the same shape and size as that triangle there. So if we want that, let's redraw that. Let's redraw that. So this time I'm going to draw it as triangles. I'll try as best I can to get the diagram correct. There's one triangle. And there is our rectangle. Work out the area of the rectangle, so it's this length times that length. But the area of the triangle here is half of the whole thing, so it is half of that length times that length there. Let's go for red, shall we? So the area of that part is, if we have that length there, A, and no, actually I'll put height, and I will change that to base. Area, have I got that there? Area of the rectangle, the whole thing, is base times height. That's the area of the whole of the rectangle, base times the height. But we are in fact interested in the triangle, so it is half of that, and we end up with this being, and 1 over 2, half times the base times the height. That is why you have this particular formula. But the interesting thing is, it also works if you have a triangle that does this. Half the base times the vertical height. It still works out. I'm not going to show you how or why or prove to you that this is indeed the case, because I don't want to confuse you. Just keep in mind it is half of this times the vertical height there, that vertical height there, half of the base times the height, half of the base times the vertical height. Straightforward. Remember it. Just seeing it once doesn't help you remember it. Write it time and time and time again. Repetition helps you remember. Alright? Remember, this is an overview. It is not actually doing any calculations. Next overview, our friend, the circle. I'm afraid you are just going to have to remember this. That is the center. Let me just put a line through there. Then I'll go from there to there. That is called the radius. And we want an arrow at the end. That is the radius from the center to any point on the edge. There is the radius. and we can give that the letter R. Some people use lowercase, I've used uppercase, it doesn't matter. Our area, you must remember this, area equals pi r squared. There's no way around this, you have to remember that. A lot of calculators have pi in. Has this one got pi? Wait. There it is. There, look. There it is. So if R was, say, 6, area would be shift pi times 6 squared. 36 times pi. Use pi because pi is one of those magic numbers that just keep on, the decimals just keep on going and going and going forever and ever and ever. They never stop. Using that symbol is precise. Trying to round the decimal is not precise. Unless they tell you to round the decimal to a certain number of places, use pi. Right, that's the overview. Now we can look at perhaps some examples which will be in the next video.